Hello everyone, hope you're having a good day. This is Mr. Vorchheimer here. I just want to quickly take you through the 1.3 notes angle addition postulate. So that's where we are in the OneNote. So first things first, I just want to take you through a little bit of notation. So this symbol that we're looking at here means congruent or is congruent to. So that means they're the same shape and size. So if we look at the two angles on the left, zoom in here, we can use our congruence marks that we talked about when we were doing the segment addition postulate to indicate that these two angles are indeed congruent. So if we look over to the right, this symbol means is equal to. So the measurement of angle A is equal to the measurement of angle B. Their measurements are the same. So if the measurement of angle A equals 30, then the measurement of angle B equals 30. So moving on, we have the angle addition postulate, which states the measure of two adjacent angles add up to the measure of the combined angle. So the measurement of angle BAC, so I'm going to color code that one in red here, plus the measurement of DAC, I'm going to color code that in green here, is equal to the measurement of BAD. So that's the whole thing that I'm going to indicate in blue here. So we kind of harping on it a little bit with the segment addition. Same thing with the angle addition postulate, that the part plus the part is equal to the whole. So our part in red plus our part in green is equal to our whole angle in blue. Okay, so let's move right into some examples. So example 1. So we've got an image on the right, some measurements of angles on the left. Let's label our diagram and label our angles so we can kind of figure out what the heck we're talking about. So this first angle here, the measurement of ABD, I'm going to highlight in red. So that's our angle here. I'm then going to highlight our second angle, ABC in blue. That's here. And then I'm going to highlight our third angle, CBD, here. So now we can use the relationship that we just learned, our part plus part equals whole. So we have our blue part, angle ABC, plus our green part, that's angle DBC, is equal to our whole, which in this case is our red angle, which is angle ABD. Now we can write down what our parts are equal to. So we have our blue part here, angle ABC, which is equal to 6x minus 2, plus our green part, which is equal to 12x minus 1, is equal to the whole, which is our red part, which is 10x plus 45. So as we kind of talked about with the segment addition notes, now we've pulled all the geometric reasoning. We've done all the geometry parts of this problem. We've identified what our part and our part equals whole is. We've identified which angles are which, and we identified our equation. So now we can solve this like any other algebraic problem. So as we combine like terms, we have 18x minus 3 is equal to 10x plus 45. We get 8x is equal to 48. Just going to move some of my work up here. If x equals 6. Now, we were asked for x, but we were also asked for the measurement of angle ABC. So, same idea as the segment addition postulate, because these ideas are kind of similar, and they build off each other. We are going to plug that back in. So we have the measurement of angle ABC is equal to 6 times our x minus 2. And for that, we'll get the measurement of angle ABC is equal to 34 degrees. Okay, before we move on to example number 2, I just want to take a quick second here and just emphasize that because the notes are this way, because they're through the screen and I'm talking to you through a video, you can work through these notes at your own pace. If you think I'm going too slow, by all means, speed me up. If you think you missed something, obviously rewind, pause, do anything you need to do to be able to work through these notes at your own pace. So for example number 2, I've highlighted our angle measures on the right and the corresponding angles on the left. Spare you the agony of watching me highlight the different colors. So we are tasked with finding the measurement of angle CBD and the measurement of angle DBE. So let's start with the measurement of angle DBE. So we recognize as we look to the left that our entire angle, the entire angle in blue, ABE, if we take our green angle measure away from that, we recognize that we're left with that angle DBE. So let's take our blue angle measure, which is 111 degrees, subtract our green angle measure, which is 92 degrees, and we're left with 19 degrees. So the measurement of angle DBE is equal to 19 degrees. So moving on, we recognize that we're tasked with finding this middle angle here. This is the one we're looking for, CBD. Now we can recognize also that now that we have this angle here, if we find this angle, we'll be able to find our middle angle CBD. So let's do that. Let's find, sorry about that, having a little bit of trouble with the software, but bear with me. So we're looking at this angle over here. So we've already found that our angle DBE is 19 degrees. We have our entire blue angle here, which we know to be 111 degrees. Now, if we find angle ABC, we can take those two outer angles, our one that we know is 19 degrees and ABC, and subtract that away from our bigger bluer angle, and we can find our angle measure CBD, the one in the middle there. So that's what we're gonna do. So to find our angle A, the measurement of angle ABC, we recognize that we can take our bigger angle, our blue one, which is 111 degrees, and subtract our red angle, which we know to be 74 degrees. When we do that, we get an answer of 37 degrees. So that's our angle measure for this angle here. We know it's 37 degrees. So now that we have that angle, we can look at our big blue angle, angle ABE, recognized again is 111 degrees. We can subtract our 37 degrees of angle ABC, subtract again our 19 degrees of angle DBE, and we're left with 55 degrees. And that's our middle angle here. Since we took away both of the outer ones from the entire thing, 5 degrees here. And again, that's what we were asked for. We have measurement of angle CBD. So the measurement of angle CBD is equal to 55. Okay, so as we move on to example number 3, again, I've taken the liberty to color code and highlight the diagram on the right, as well as the measurements of the angles on the left. So as you see in this example, we have degrees in minutes, which we talked about a little bit earlier. So that stuff is going to keep coming up in the course. So we want to make sure we have a good understanding of that first. Now, we are tasked with finding the measurement of angle PYH. So if we look at PYH, we can recognize that if we take our blue angle plus our red angle, that will give us PYL. If we take that whole angle and subtract the green, that will give us PYH. So let's do that. Let's find the entire angle, the blue plus the red. So to do that, we are going to take our 29 degrees and 16 minutes and add our 13 degrees and 44 minutes. And what we'll get here is we'll get 60 minutes on this side, and we'll get 42 degrees here. So we have 42 degrees and 60 minutes. So I want you guys to recognize again that this 60 minutes is equal to 1 full degree. So this is also equal to 43 degrees. So now we know our angle PYL is equal to 43 degrees. So as we talked about, now we know the big angle PYL, we can subtract the green angle, which is HYL. So to do that, we'll take the 43 degrees and we'll subtract our green measure, which is 31 degrees and 24 minutes. So you recognize again that we can rewrite this top part as 42 degrees and 60 minutes. And this will just help us subtract so we can subtract easier. So 60 minus 24 is 36 minutes. 42 minus 11, or minus 31 is equal to 11. So we have 11 degrees and 36 minutes. So that's our angle, the measurement of our angle PYH. So 11 degrees, 36 minutes. Okay, so I've erased that work, but by all means, if you need that, please rewind. I've also written in the big angle measure we found, which was 43 degrees. Now all we're looking for is the angle measure of HYI. So to do this, we recognize we have our blue angle, and we can subtract the angle we found, which was PYH, and we are left with our angle measure HYI. So to do this, we have our 29 degrees, 16 minutes of our blue angle measure. We have our 11 degrees, 36 minutes that we found was PYH, and we are subtracting these. So again, to do this, we can take one of our degrees and add 60 of our minutes, because 1 degree is equal to 60 minutes, and we can rewrite this as the following. 28 degrees and 76 minutes. Now as we subtract these, this becomes a little bit easier for us. 40 minutes, 17 degrees and 40 minutes. So there is our third angle measure. Okay, so now I want to go over what an angle bisector is. So the definition of an angle bisector is a segment or ray that divides an angle into two equal parts or divides an angle in half. So whatever way is easier for you guys to think about that. I prefer two equal parts. Helps with a little bit with our relationships that we're going to establish below. But whichever way is easier. I want to also note that you can kind of think of this, I want you guys to think of this the same way that we thought about midpoint. So midpoint divided our segments evenly in half, so we had the two equal parts. Same idea with an angle bisector. It'll divide the angle into two equal parts. So if AC bisects angle BAD, what relationships can we make on the diagram to the right? So we know we have our part plus part equals whole, so we can have our angle BAC plus angle CAD is equal to our entire, or our whole, which is BAD. So this is our part plus part equals whole. We also have our half equals half that we know. So we have BAC is equal to angle CAD. That's our half equals half. And we also have our 2 halves equals a whole. So we have 2 of angle CAD is equal to angle BAD. And this is our 2 half equals whole. So let's move right into example 4. So in example 4, you can see our congruence marks that we have. So this simply means that ray HF bisects angle EHG. So because we know that, we can look at our relationships and we can recognize that we are given EHF and the measure of angle FHG. Because they are both equal, we can look at our relationships and we can see that we can set them equal to each other. So 2x plus 10 is equal to x plus 18. We can solve this. We get x equals 8. And now we're asked for the measure of EHG. So that's the entire angle. So we know that our x equals 8, but 2 of angle FHG, which is x plus 18. So we can plug our 8 in for x. 8 plus 18 is going to equal the measure of angle EHG. When we do this, we should get 52 degrees is equal to the measure of angle EHG. So for example 5, we are given that ray BD bisects angle ABC. So again, it might be helpful for you to draw a picture. So let's draw angle ABC. And we have our ray BD that bisects this angle, excuse me. And because it bisects, we know that these two angles are congruent, so we can draw our congruence marks. Now we can look at our drawing and look at what we were given. So we were given ABD, and we were given the entire angle ABC. So now we can go back and look at our relationships and look at what we might want to use. So we were given one angle and the entire angle. So this might be helpful for us to do 2 of half of our angle, so this bottom one here, 2 times our half equals our whole. So if we relate that back to our problem, we have 2 of our half, which is 8x minus 20, equals our whole, which is 10x plus 2. So again, now we've done the geometry part. Now we just have to do the algebra part. So as we distribute that 2, right side looks the same. We get 6x equals 42. X is equal to 7. So we are asked to find x and the measurement of angle, this should say measurement of angle DBC. So we're asked to find those two things. We found x was equal to 7. Now we know the measurement of angle DBC is equal to the measurement of angle ABD. So if we plug our value of x in for our measurement of angle that we know for our measurement for angle ABD, we have 8 times 7 minus 20, which is equal to 36 degrees. So the measurement of angle DBC is equal to 36 degrees. So is our measurement of angle ABD, because these two angles are congruent.